Welcome to my satisfactory stream. Just kidding. Right. Just waiting for the project to load. Sorry, I'm a bit late. Thing running smoothly, sounding good. Let's go. So, I had a bit of a dig into the problems we were having with the room interaction, and I think it's a bug. And simple solution is not to have them. When the level loads, it has problems. If you load it and they're separate and then you move them around, it's fine. So we're going to do that. It's not worth me fixing because that system is being rewritten. And so the code I'm using at the moment is kind of irrelevant. So I won't do that. Are we running? We're running. Got a window yet? Yes, window. Okay, we can watch the loading screen. Yep, so that's fine. We can ignore that for the minute. I did a few things off stream when I was investigating that, kind of thinking about what to do next. And I was mentioned last time about some extra asset packs in this sort of space station vibe, and there are a couple more I've added. So we can have a look through those assets and see if there's anything we can use. I have gone in and grabbed a few of the wall and floor panels from the other asset packs, which kind of match and look fine, and I put them into the resource lists. What else? The other thing. Oh, and I tidied up how those assets are positioned in the sort of wall surface, so they're a bit more uniform and follow the same surface. Some of them are different thicknesses, and it was pushing them to different depths. And you can probably see got some nice extra bits appearing on the ceiling here. These are, and everything's a bit flatter. I found a couple more wall panels, which we'll talk about in a sec. And yeah, so as I was saying, because of these new, because of the way that some of the extra panels are sort of different thicknesses, it means that the outside, the behind the scenes, it looks a bit rougher, but that's fine. And these should, if we do this, should be fine to interact now. So once it's loaded, we can, oh, that's nice. Once it's loaded, we can move these things around and do that. And yeah, once it's loaded, we can move them around and burn them up, and then have a little look around. What it's looking like inside. Ooh. Yeah, so a few more greebly panels, a bit more uniform. New wall panels found, things like this. We'll go through the asset back in a minute to show you, but basically we now have a bit neater, a bit more uniform. Everything seems to be working okay. Yeah, because we've added some more wall panels, we've lost the number of. It's reduced the number of windows. The windows are just treated as wall panels, so I'll just choose them at random at the moment. We might want some sort of how many windows or what proportion of windows do you want in your room as a control. But yeah, that works quite well. The new panels, and here, yeah, I quite like these ones with the little sticky out nubs. Yeah, it's looking very much like the preview pieces. Good. I'll show you what back out to here. Yeah, so that means that When I switch levels, I'll need to redo the layout, but that's probably fine. For development, we'll just be working with one room anyway, so that'll be okay. Let me show you some of the other assets, and then we can talk about what I'm going to think about for this stream. Right, so we were working with this pack here. If I do that, you can see this was the pack that we're working with mainly, and then there's two others. This one has got more of the same sort of stuff, plus some extra features we may or may not be able to use. I was wondering about some of these as alternatives to these edge pieces here, which might work. So we could have a look at that at some point. But yeah, most of it's sort of external stuff. There is some internal things like screens, and these are not. I don't think these are really windows. They're more like dividers and panels. And then also there's these crates at the top, which are quite nice. We might be able to do something with those. So the rooms are all obviously empty. It'd be nice to put some things in them. So maybe that's what we'll do today. We're going to put some crates around and look at how we can get them to stack, things like that. At least look like they're stacked. The other pack here, it's a slightly different style, and it's got a lot more detailed things. I have taken a couple of these panels. I think I took. Did I take? I may not have taken any of these panels yet, but they don't quite conform to the same structure. Sometimes they do, like this is a 2x2 ceiling mesh. But there's lots of sort of constructional pieces. Lots of pipe work, which is interesting, with joining pieces. Might be able to do something with that. Other gantry steps. Also, we got more walls. Anyway, we'll have a look in the actual test levels. So here we've got I'll load this up. So this is, as you can see, I've been testing my procedures with these assets. So I dropped in a couple of the floor, and so that's floor, that's ceiling, and that's the wall, because as I was adding in assets to the resource list, it's good to see what they look like in context. So this is the kit here. These are the crates I was telling you about. A few new pieces. I mean, some of these look like they're like floor or ceiling pieces, but I decided to try them as wall pieces, and they work fine. They needed a bit of reorienting with the fix-up stuff in the resource list. Use the noise. There might be someone at the door in a minute. And yes. So I was looking through some of these. Some of these I've added as wall panels. I haven't done these, kind of like internal ones. Some of these look a bit like doors, but I just put them in as wall panel. I'll have to put those ones in. The wall panels we only support the long ones at the moment, so we'd have to do some changes to incorporate shorter ones. So I've taken a few bits and pieces. These crates look interesting. Might play with those today, so we'll come back to those in a minute. But as I added stuff, you can see I had it all set up on the panel here, and I've kind of unified the way they sit relative to each other, so it's nice and consistent surface without anything kind of like rectangular sticking out. Floor was kind of like that anyway, but I did make sure there was a couple of pieces I had that needed that. And then these new wall panels I put in, again, they needed a bit of jigging backwards and forwards to get them to sort of sit properly. You can see they all sit slightly different depths to get the same effect. Largely this stuff is external, we don't see it, so it's not a problem. But it does make it look quite an interesting thing going on. So that's this pack. The other pack, let's have a look, there's more stuff in it. But it's a different style, it's different colour certainly. You can see there's a few more pieces. It's got a similar vibe with the whole kind of walls. It's a little bit grungier, a bit more rusty kind of based, rather than more science fiction-y, more conventional space station-y, which is kind of cleaner, I guess. A bit more funky. going on here. Yes, there's lots of interesting pieces. A lot of complicated, like stuff that's going to be actually quite complicated to put together. But there is quite a lot of it we could probably just use. Like I'm sure that we could make this into a wall panel and it would kind of work. Windows going on here, which I quite like, and with the grungy kind of screen effect. Good floor pieces. The pipe work I was telling you about, that might be quite good to play with. And some stuff. Yeah, make interesting things. Tanks again. I don't know if the pipe work would connect to that or not. Lots of panels. These are quite good. Probably stick some of these in as wall or floor. Probably ceiling. What else have we got? Railings. Railing kit. That's quite nice. If we wanted to sort of demarc areas, or we had stairs and different layers, we could do that. I mean, it does get, everything gets more complicated the more you add, but it's something we could do. Oh, and these look like these would probably work as ceiling or wall panels. I'm not sure if they'd fit the style, so we might leave this kit for the minute. Might be good for a few objects and things. It's got these interesting rail things. I don't know, I'm not sure about this kit. So we'll go back to the other one and have a look at the rates for the minute. Yeah, because I want to look at putting some stuff in the rooms. So I'll talk about the original, the way. So if you've seen my original dungeon generator using Apparance, there's a certain styles. Some of the rooms have different purposes, and one of them is like storeroom, and that uses basically stacks up loads of crates and barrels along in the corners and out of the way. And there's some logic there to avoid getting in the way of doorways or stopping you getting between doorways. And there's just some simple logic we use to do that. We can do a similar thing here, so that if you've got two doors on your room, it can make sure that it doesn't put crates in front of them or anywhere between the two. And there's simple logic you can do to build to make that happen. And we're going to try some of that. So what have we got here? We've got these crates. So this one looks like kind of a unit cube. Let's have a look at the mesh. So it says, look at that in here. Okay. 140. So it's not quite a meter cube. It's a bit bigger in a couple of axes. It basically is though. This one is probably a little. Yeah, they're all kind of a bit different and different sizes. The heights again. What height that is? That one is. Yeah, so roughly a square meter by a meter and a half. This thing is probably the same but on its side. 1.6, kind of right, yeah. This one, big in both axes. Oh, they do get bigger, and there's one that's 1.5 by the looks of it. Is that 1.5? Roughly, yeah. So there's all the different combinations of meter and meter and a half. 1, 2, 3, 4, 5, 6, 8. Yeah, that makes sense. That's two values in each axis, which is 2 to the 8, 2 to the 3, which is 8. Yeah, that's all the combinations. So we can use those. I think. So let us play with this a bit. So first thing's probably to find the spaces that we're going to populate, and then make some decisions about if they're big, if it's big enough to fit some of these things in. We can put these rates into resources as variants. Probably by the footprint. We've got those 3 footprints. think we've got 3 footprints. 1 by 1, 1 by 1.5, and 1.5 by 1.5, and then different orientations, but we can correct for those orientations and treat them the same. So like this and this, have I got the yeah, I'll turn it back on. You can see things being selected. So these 2 we would treat, in fact these 3, these 4 we would treat as the same footprint, and we just rotate, we reorient them. They are basically that. So we've got 3 different footprints we can choose from. And maybe that's what we'll classify them by. And then either we can choose at random from those lists. Maybe it doesn't matter. We'll see. We'll look at the space we've got available and then see how we want to divide that up and populate it with crates, because there's different things we could do. We could have a regular stack, like we choose one type and that's we grid them in 3 axes with some variation, or it could be more ad hoc and we just choose one at random, position it, and then decide where the next one can go until we run out of space. That works as well. And then any boxes we've put down, it can always stack more on top of either the same footprint or a smaller footprint. Would probably work fine. So we'll have a look at some of that logic. First, let's look at the space in the room, and then we'll look at the stacking if we get time. We might not get time this time. It's probably more fun to look at the stacking, but then that makes assumptions. I guess we are going to be filling a space. Let's do a cursory look at the rooms first. Then we'll come back to these crates. Right. Back to the test map. So we're going to play with a room. Let's do this one. Move it over here a bit so we've got some space. I'm going to make it a bit shorter while we do this. Right. So this is a room. Funny that. Might add a door here. So for the purposes of, in fact, let's make it a bit. There we go. Nice clear floor. Okay. So we've got a room. We've got 2 doorways. This could be this could either be a doorway specified here, or it could be because of another room. But we still get that information in this room anyway, whether it's a gap or not. So we do know which sides have doors and where they are. Now, what I did for the dungeons is it's kind of splitting based on what sides have doors. You can split off useful space. So one thing you can split off is what's the easiest way of drawing on the screen. Here I am, hugely prepared for this. I think I can. Yes, I'll just use the select. So this corner between these doors, there's a space here that's available. I can build out this way until I hit the door, and I can build out this way until I hit the other door. That's one space. I can also build out all the way down this wall because there's nothing on it until I hit this door. And I can also build out from here all the way up to this door. Now those 2 spaces will overlap in this corner here. So you just need to decide a precedent of that. It's a bit complicated because the rooms, there's lots of different combinations of, there's 16 different combinations. If you actually want to be able to get into the room, of having a door on a wall on each of the 4 walls. We may in the future also have multiple doors, so we should probably keep it simple for now. I think what the best plan is to collect together spaces based on starting on each wall and looking at whether there's a corner created by 2 doors or whether it's a fully open wall. And this is the sort of logic I did for the dungeons. So we should we can start by getting that space, drawing a bounds, and then doing some like logic on it and checking the various door characteristics. We probably need to know the minimum and maximum door of like in position of any doors. If we have multiple doors, we can just ignore any space between them for now and just treat it as just the ends. So we'll need the min and max extent of any doors, so we can work out that logic. Then there might be a bit of jiggery pokery to choose which pieces of room we're going to do things with. There's another option as well, which is that you could use, if the room's big enough, you could use the center of the room and leave the outside clear. And that guarantees you're not going to hit any doors anyway. But that also might be nice to be able to do that in one corner. So this room, for example, you could actually build. Oops, sorry. Could actually. What was it? Could actually build out to like here and still get through the room. That's another option. I guess it's kind of like the. Yeah, it's complicated. We might just do a dividing up thing. Anyway, let's start playing with the logic. I'll throw in a procedure for visualizing some stuff, and we can see what we get. It's quite likely that we'll end up with a procedure that's applied in multiple times, so analyzing the situation from different points of view, like based on this wall or this corner. So we could do that. I think we should start by picking out the corners that are empty, and then we'll look at sides that are empty, and also decide if how we're gonna overlap those. Whether or not a corner is going to be, we choose between using the smaller corner or the larger corner. We can classify them like that, maybe. Right. Here's our. Let's put a room down here. I'm going to make it even shorter actually, because then it's easier to see what's going on. Right. Procedures. Look at those again. How do they work? Okay, so we're thinking about this at the room level. So it's going to be at this level. We're going to need some information about the walls, basically where any doors are. I mean, we do have that information up here. Maybe we can analyze it at this stage, but there'll be some analysis per wall, so we could just include that in here and take it from there. That might be the simplest thing to do. Incorporate the logic in here. And then we have this center space here, which I think so let's start with the procedure for room contents. Decide what to put in the room. Now we could have different themed rooms again, like this is a storeroom or this is a control room or something, or different algorithms. It could be that, hey, we're just going to scatter stuff. We're not going to be particularly interested in storing big crates or anything. So it might be worth abstracting another layer just to say to the decision further. So we could do, let's do contents storage. Can't spell storage. Focus on that. We're going to use the big crates. We're going to pack as many as we can into with some logic that means it's still a usable room. Sometimes it's corridors that are used for storage. Sometimes it's just got one door, and then it means we can use more of the room. But you still want to be able to get to things. Maybe that's the logic we use. I mean, if there was only a door at the top, you wouldn't want to fill the room completely just because you can't go anywhere. You want to maybe leave some corridors, some spaces free. Yeah, I wonder if that's a better way of thinking about it. Generally keep the center and both axes free, and then it's 4 corners. We could use that logic. And maybe if a door is too far to one side, it doesn't. Those corners just are too small, and it doesn't use those, or it doesn't use it on that side. We get a kind of like cross shape, but with optional offsets to it up to a certain point. Might work. Who would do that? So then it's simple. We're not dealing with whole sides. It's always corners. Then you've got some space to move around. Don't really want to fill the room completely. Let's do that. I think we're going to do that. So it's corner based, and then the doors can influence some of the positioning of those like access ways. I think we'll do that. So as I was saying, storage, content storage. So these are going to be, so this is going to be a procedure that takes a space and then generates some stuff to go in it. So to start with, we're going to have a frame. Let's just show the space. And in here, we're going to use that. Sorry, I realise I'm out in the way. Let me move this over a bit. There we go. Yes, so the room contents. We don't need to put it at the full bounds because that's got walls in it. We're just going to use this center. And this is content here. Dink. Right, so let's see what we get. Okay, we've got the bounds of the space, but we seem to be inside the floor, which is not what we want. So we're going to need to squeeze this in by the floor thickness. Don't know what the floor thickness is, but I'm going to think it's 0.25. Let's try it. Just shrink it vertically a little bit and see what we get. It's not vertically. That's vertically. That's too much. Oh yeah, that's half. Nope. That's shrinking it to that proportion. We want it to units, and we want it by that amount. There we go. So that's now, yeah. This is our space that we're going to fill. Gives us freedom to keep away from the walls. They're all recessed as well, which helps. So even protrusions don't impinge on the space. So that's going to be the space we're going to put things in. Right, and in here, so then the idea was it will choose between the room type. In this case, we're doing storage as a specific thing, so bring that in, but that doesn't do anything yet. Again, let's show a box. Okay. Let's put a storage colored box in here and use that instead. Okay. So this is our storage. That's not right. So I talked about splitting it into 4 corners, but with different potential offsets based on where the doors are. So there's a couple of things we need here. It's kind of like a 9 slice, but it's not regular, I think. We also need to decide how the middle is going to work. I think it might just be that it is just the corner, assuming, yeah, if we assume that each wall has a door, and if it's not actual door, it's in the middle, that'll give us our sort of gangways to access all the storage. And if there is a door, we'll use that offset so that the gangway lines up with it. So that's effectively 4 corners based. We need to know where the doors are and then use those to generate those 4 corner spaces. So let's do that. I mean, that's probably something we can generalize. We should generalize. So let's do that. It's going to be a room was room contents. Let's call it content. Content space. This is hiding the space available. Okay, this is going to be our logic for that. These I will rename to be content, and I will do content type storage. Okay, content space. So this was going to be we take the room, we take the door information, and we output the 4 corner pieces that we're going to put things in. I think that'll probably do for now. Is that something yeah, we'll probably do that as 4 sub procedures because there's 4 corners and it's the logic to work out that. So let's go this corner size corner is for content. We're going to need, again, doesn't do anything. What that's going to take in, well, first of all, it's going to make a frame because this is our bounds to put things in. Going to generate a space which is going to be a corner frame that we can put stuff in, and we can visualize that in a minute. It's going to be based on the room frame, so we need an input here that's going to be the room, and it's going to need information from, we need to know which side we're working with, and if we might be able to, that's probably a good idea. Excuse me. So if this logic can be the same for all 4 corners, and it doesn't have to know which orientation it is, because we could normalize that. We could, does that work? We'll see how that goes. With the space we need for the corner we're doing, we need the 2 where the 2 doors are. Information about the doors. We have the offset of the door, whether there is a door and it's offset from the center. So that would be easy to, they're centered. That would be easy to, you know, I said we were gonna, there isn't a door on a wall, we'll just use the center. That's easy because we just have an offset of 0 when there isn't a door. So we can pass this in as 4 offsets. We'll just make those conditional. Do I want to do anything cleverer than that? No, I think for now we'll just do that. Let's build that into a structure for now. Yeah, I'm just going to build that out here. Let's do that. So for a given door, there is one, we use its offset, otherwise 0. So this is the west door, and let's do the same for east, south. If there's an east door, use its offset. If there's a south door, use its offset. If there's a north door, use its offset. East, south, that's north. What I might do, just so I'm not passing in loads of values, and in future I might decide that we do want this information of whether there's a door or not. So it's going to be easier to pack up if I build it into a little structure. So I'm just gonna put these into a list. Structure is it? It's just a list of door offsets. So this is our door. Okay, and then we can take that into here, and then into here, and then do things with it. So if we wanted to get a one of the wall sides out. We can break it out here. This is the door info. This is all the doors. I'll take that back out as well. Content, door info, and then out here. There. So now we have in here a list of where the doors are on distance from the center on each side. For now, I'm just going to break these out because I think we're going to. No, not. Content space is going to do that. That's in here. We want to do the calculations based on the 4 situations, so we're gonna need that in here. Do that here. No, we're not using that yet. Space. There. We're going to output these 4 here. So this is to northwest space, northeast space. So these are corners, there'll be corner coordinates. They're all going to have their own one of these, so we can actually duplicate those. Once we know what they need, we can hook that all up. This is the logic to calculate the corner space based on the bounds and the door info. And we're just going to have a room. Yeah, that's fine. It is the room space. This is the whole room. We'll deal with the orientation and everything in a minute. I'm going to get so each one of these will need a different set of door information, like the 2 doors near it. It's not going to be that straightforward. There's going to be some wrangling needed as the orientation and relativeness changes. But basically, these are going to be for sides. So this will be, what do we say? It's west, east, south, north. This is west, south, north. Okay, so we've got the door positions. Let's go here. So we're going to need to. Alright, they're not being calculated yet, so they're not. Yeah, there's no output. We can hook them up and visualize them. So let's have 4 colors: red, yellow, and oh, hang on, that emerged. Can't do that. Let's just bung a big one in just to make sure we've got enough in case we want any diagnostics or other stuff going on. Green. So they're all the same place, so you can't see them at the moment. But right. So once we've got this working, we're able to see these appear as 4 coloured pieces. Hi everyone, welcome to my stream. Hope you're enjoying it. Any questions or just any comments? Pop them in the chat. That'd be great to interact a bit. I mean, this is the nitty-gritty logic stuff going on. There's no right way of doing this. It's just you basically codifying some decisions about how you want to do things. In this case, I want to use the space in a room to put storage containers, but there are constraints like they don't want to be in the way. They'd probably be stacked in a corner. They don't want to be in the way of any doors. We still need to be able to get from between the doors. there's different ways you could codify that and express it. But I'm also saying, actually, we don't want big chunks of storage. We need to have it split up so you can get between and get to all the boxes. Maybe if a corner is large enough, we decide to fill it with boxes, we'd still want to split and have aisles. We can do that in the actual stacking stuff as well, but rather than the room division. Maybe we do it in the part of the room division, I don't know, because there's... Yeah, we could do. Because the logic I'm building here for where there's spaces to put things in a room, we could use for other things, like it could be a canteen and there could be like desks, or an office and there could be desks, or a workshop and there could be like bays and things. So it's that kind of thing we're trying to do, and this logic is also useful in a small, on different scales as well. We could say that, hey, this part of a room has a similar requirement. I need to be able to get from here to here, like the doors, and I want to know where I can put things that aren't in the way. So yeah, there's that. We can do all that. So how do we go from we've got the room, we've got where the doors are, we want to do a corner, but we want the same logic to be able to do all 4 corners. So how does that work? Now, there's different ways of doing that. And one of them is to rotate everything around for the corner you want. So you're always doing it in the same axis, maybe from positive X, positive Y. And then do the logic, and then the result you rotate back by the same amount. And that works. That's good. You could kind of bespoke the logic, say you could do a lot of that sort of like preparation outside of the repeated bit, but that kind of wastes the whole point of the repeated bit. So what it might be, the ideal case is we give it the room, we give it 2 bits of door information, and we tell it which corner it's in, and then it works everything out. And that's the best way. And so we could have that, and we could start with that and see how it goes. So for example, if we're doing the northwest corner, we'd pass in the north door and the west door information. But you'd need to know whether it's the horizontal or the vertical, and then which side of the room you're on. I mean, I think we could probably work that out. And then we also have west, east, south, north. We also have a kind of like side count index we used out here. So these we did this thing where we said this is side 0, this is side 1, this is side 2, this is side 3. We can have the same logic for the corners and have it use that to work out where it is, and then do the calculations appropriately. So let's start by saying the corner knows which corner index it is. I mean, can we unify that? We've got west, east, south, north. West, east, south, north. Right, so if we did bit 0 is west, east. And bit 1 is south, north. We can get the 4 combinations. Similar to that, but not the same. I mean, it wouldn't be the same anyway. It's a different corner, not a side. So let's do that. Let's add a thing here for the corner. So 0 equals southwest. Yes, because 0, yeah. Let's do it like this. 0, 1 equals east. 1, 0 equals northwest. And 1 equals northeast. So from the bits in this 0, 1, 2, 3, we can work out which corner it is, which side of which side of which axis we're on as well. We'll go with that. So means we can do, this is southwest, this one can be southeast, one can be first. I mean, sometimes it's useful that it's the rotation, like 0, 1, 2, 3, clockwise or anti-clockwise. Difficult to reconcile the two, so I'm not going to try. If we need to like orient the right way, we'll deal with that with some logic. And this one is northeast. That's that information. So we are going to need, for each corner we're looking at, we're going to need a horizontal door position and a vertical door position, because the corner has one of each. So for example, on the southwest, it would be the horizontal would be the south one, and the vertical would be the west one. So we could classify them as that. We'll just add 2 floats for that. So we've got let's call them. It was very confusing. Are we using a door with the coordinate in the y for, or are we talking about the x sides, or is it? Might be simpler just to be explicit and say, right, I want to know the west or east wall door. So let's go door west east and door south north, because that's what they're going to be. So for the southwest, this will be the west door and this will be the south door. Now we can hook those up. So we've got the R4 here. So for southwest, we've got the south. It needs to go into the door south, and the west needs to go in there. For southeast, we've got southeast. For northwest, we've got. Label that wrong. That should be. Oh no, that's right. That's right. South. Sorry, northwest. We need the north, the west, and here for the northeast we need the northeast. So these should have all the information they need. Let's do some simple logic. So let's at least get these cubes appearing in the right corner, so we can split off the relevant side based on this. So if we can pull out which side we're on. So this is, are we east? Which is bit 0, and then we've got also for bit 1 we've got some binary and bits and integers and stuff. Bit old school, but it's true, works. How are we doing? Oh, we're going to run out of time. Oh well, we'll keep going. I'll run for another half an hour or so. See how we go. Messages. What are these messages? What I was gonna check. Sorry, I'm just checking some messages in case anyone's telling me something drastic has gone wrong. It was worth checking. Seems all right. Continue. Hello, everyone. So this one's going to be north, not south. So we can do some logic based on which corner and side we're looking at. So if we use this to split sideways, and then in the X and in the Y, we can see exactly what we're dealing with. Was it going to be a split? I might split. I'll do it as a split. Because the amount we're going to split off will depend on where the door is. We'll come back to that in a minute. Let's just get these our 4 cubes away from the center. We can do that with a split. We need 2 because we're dealing with. So got this space. So we're going to split. Let's do that in a minute. So east-west split. Basically, it might be what we're going to do, what I'll do is I'll split it. Yeah. So we need to split by. I'll come back and we'll just do it as a one unit. So we want to split off a bit off one side or a bit off the other. So that could be better done as a. Either we do the split and then select, or we do. Yeah, it's going to need to be a bit of both. There isn't really a way of. Oh, actually, I could just do the size. Do size. Oh, that's interesting. That's an interesting way of doing it. Let's do that. So resize. If we take this and play with it a minute. So if we split the size units, oops, keep that one whole. You can specify whether you want it lower or upper in each axis. So we could, given that we know east or west is this decision, so that's going to be changing this value. Now these are these are enums, or yes they are, and but they're all just stored in an integer. And if you need to know, if you want to drive one of these inputs, you need to know what values to use. And it's not immediately obvious, but what you can do is if you hover over where it says integer, it'll tell you the value of the current selection. So 2 means upper edge, obviously center means 1, and lower edge is 0. So if we wanted to switch between left and right, or lower and upper, we can switch between 0 and 2, which if we do that here, so it's set that it's on the east, which is true, which is the upper. So if we do that, there we go. We have split now. And we can also, in the same sense, do it the other way with the north-south. In this case, if it's set, it's north, which is going to be the upper. So if we do that, I've split it. So now our 4 instances of this procedure are doing different things because of the corner value. Let's double check how we had this set up and see if we're correct. So northwest, okay, we've got, I think we might have the north-south reversed for some reason. Northeast, yeah, east is those two. Okay, so north-south is reversed. Why is that? Relative north, not south. North to north. That should be north, unless we didn't have that. North. Okay. Northwest. Oh, these outputs are labeled different to these. Or the other way of looking at it is I've hooked these up wrong. So north and south is backwards here. So south. Let's rehook these up. Southwest, southeast, northwest, northeast. There we go. I might untangle them. No, I'm not. I know what I'll do. I'm going to leave these in order because that's the number order we decided. I'm just going to rearrange these here. This doesn't affect the pages at all. It's just a visual thing. So now these are all mixed up. So these two are the other way around. So I'm going to tidy these up as well. Right. Oops. Okay. Northwest is red, northeast yellow, southwest green, southeast blue. Okay, so we've got simple corner spaces. That's not quite what we're after. We really want to say, okay, so the next bit of logic we need is to work out how big to make these things. And it's going to be based on the doorway on the side that we're looking at. well, we're going to need this, probably need this information again, but for now we'll just, okay, this is our, right, this is the bit that chops it up into the corner we want, and this is the size. So we should extract that out to be a separate values, because we're going to need to set them independently with 2 bits. So we've got 2 bits of logic based on the doors. One is how wide the thing is, and one is how tall it is. And the width is the east-west thing, which is the x here. We can this width here is going to be based on the south-north door, depending on which corner we're in. So this value is either this door position or this door position. Is relative to the wall, so it's reversed on one side, but we can deal with that in a minute. So we need to know this position of this door and whether we care about it from one side or the other. That's kind of, let me see. So that, what did I just say? We need this. So for the north side, sorry, for the east-west, we need this south or north, but depending on which. Right, so we've got okay. We don't actually need to do any logic for that. We know it's the right door for the corner, like the side we want. We don't know whether it's reversed. We'll deal with that. This door position is going to be relative to the side. We get the size of the room. We're going to need to work out the difference, I think. Oops. So, where are we? Right. This value here is the width of the thing, and it's going to be the width. Let's just assume we're working on this red one. Is northwest. It's going to be the width. It's going to be some maths. So we've got the position of the door, negative or positive. That's relative to halfway. So we need halfway across the room. So we're going to take the room x and divide it by 2. We're going to add the door position. It's either the south or north door. But we've also got right, we can try that. Bang. Okay. Now we look at that. Okay. There's a bit of kind of working. So we can see it's using the center of the door. We need the edge of the door. And also we need to flip it if it's the other side. Because the yellow one is going the wrong way. The yellow one needs to get bigger as I go to the left and smaller as I go to the right. So we're just dealing with the red one for now. We'll sort the other one out in a minute. So the width of the door, at the moment, we've only got one door type, and I'm going to hard code this because I know it's 10 units. If I take off half of that, so later on we can parameterize that. No, that's not the opening itself. That's the whole panel. We can get away with more than that. So if we take off, yeah, that'll do. That's now flush with the actual opening, which is fine. It doesn't matter if crates go right up to the edge. Now we're from the other side. What does that mean? So what that means is our corner is on the. If this is true, then we need to have the kind of. This is true. We want the distance from the other side back, which is hang on, I've done it from the center to there. Is that? Okay, so this is the door position. And let's make, actually here's these. Oh, so I want two values that are same amount either side of the door position, so the width of the door. There's actually a little operator for that. It's called spread. Not really a common one, it's just was handy, and so I made it. So what we can do there is we specify the center, the in, and then the plus and minus, which is the half door size, gives us two values, which either side of that value. What that means is this is the two door edges. Just for convenience, it's the same as doing add and a subtract node together. But it means you get a single value you can fiddle with. We'll see that in a minute. So if we are, basically if we're on the east side, we want to do a different calculation. So let's do that. On the east, on the west, we've got the value. But if on the east, we want the room size minus that. We were working from the left to the right, so we can do another subtraction, which is room size minus the other edge, and that'll be what we need here for that. Bang. This is okay. That worked because the we're working from the left. The position of the left door side is the space size, whereas the position of the right one is not. It's this size here, so we need the opposite, which is that. In theory, as I move this around, we get two spaces. And look, the bottom started working. Is that correct? It's supposed to be in the middle when there's no door to keep some access. So that seems to have worked. I'm assuming it's all gonna fit like that. Okay. Now we need the sizes the other way. So this door isn't doing anything. So similar logic. We have got this again. We can just duplicate that. For the west east door, like so. We're on the y-axis. Let's do that. So that's the x, the y. I'm going to put a little constant in for the door size. Sometimes it's nice to be able to just fiddle with that independently. Let's do, and why not do the divide so we can be a bit neater. So that's our door size. No, it's not. It is, hang on. Oh, nope. Those are just halves. This is the door size. And it means we can fiddle with that if we need to. So, I'm just going to put it back to 4. Top space. Why divided by 2? Why have we? Oh, hang on. That one. There we go. And then similarly with this logic here, the north-south, if we've got the north side, we want the difference, top space. And if we've got the south side, we want that, and we plug it in there together. Ooh, interesting. Okay, so what have we got here? Does it work? That kind of works. It looks slightly odd. Oh, that door's slightly shut. Doesn't matter. That's fine. That's working. And then this one working too. And then if there's a door here, that would. Okay, that's backwards. The door here. Let me guess. That's backwards. So what's going on there? South, north. So these door positions are reversed for the opposite side. So we need to, instead of passing the position across, we need to do a tract. So for east, west, normally it's the east side wasn't working. West, it's, yeah, so if it's west, it's just straight door position, which we can then feed in to here. But otherwise it's reversed, which is a negative. Subtract from 0. Now that's the, is that this one? Yeah, so that's there, and then that's there. And now we need to do the same for the other one. North, south, that and that. And then we can hook that up. No, I think that might be north was fine. The other way around, strangely. So we do that and we do that. Okay. Now it's possible to generate spaces that aren't restrictive. We might need to cover this as a special case, but we'll worry about that later. Because generally we can just configure things in a way that we want. Although, yeah. So this room, for example, basic room, in here, out here, a space for things with some access as well. Right, that's getting there. With storage, we can still get through. Hooray. That'll do for starters. We now need to put some things in that space, and then we'll call it a day. Let small. Okay. So crates. We can do that now. We should start with just a simple, start with the basic crates, and we'll just do a rectangular space fill. Next time we can look at more complicated construction and layout of filling these with stuff. I think I'm not going to have time to do much more than this though. So this has given us some logic where we can split a room up. They should all now, all the rooms will now have this. Let me do that in the diagnostics. Let's turn off things. Yeah, so all the rooms are doing this. This one's got, where does this have a door? Oh no, it doesn't have a door because it's not connected to a room with a door. Oh, that's an interesting question. So if I, not that. Okay. What have I done? bring that over there. Okay. A door that it's inherited does not contribute to this logic, so that's something we need to fix next time. That's all definitely doable. Now I think what we'll probably mean doing is, so where we've got on our main procedure, at the moment we're doing the logic here, and I said we were probably going to do it in here because these will know whether it's inherited a wall because it's already doing that. We should probably gather this information from these and then feed it in here. I'll do that next. We can look at that next time when we address that issue. Nothing's ever simple. We'll come back to that. For now, we've got some spaces. We can still kind of get between the rooms. We just have to be a bit more judicious about where we position the rooms so that we can get between them. And at the moment, all rooms do this, which is not what we want. So we'll also look at switching that on and off depending on some factors. Maybe only rooms with one door are storage rooms. Maybe that's a thing. That might be a way of doing it. Maybe they're not. Maybe you need to store lots of stuff when you're in space. I don't know. Have a look. Okay, we're going to get some contents, some stuff set up. I think whilst crates are universally accepted currency in game development, I think there are other things that are stackable. It doesn't have to be a crate, so maybe we should have classify them as just a stackable thing, which we can put in storage rooms. And it could be a crate, it could be a barrel, it could be whatever. So crate is too specific, is what I'm saying. So it's a sort of cuboidy thing that could be stacked of a particular size. And we'll start with the little 1x1s. And we'll add to that next time. Right, we have in here these crates. I think that one, small one, and there is actually a tall one which we can use just so we got some variety. There's the two versions of the 1x1 footprint. Everything else is a bigger footprint. So in our resources here, we're going to set it up so that, right, so we've got various things here. Let's put in, I'm going to put it in all in a folder called content, terrible name. In here we're going to have, let me call it stackable, just because I have a hunch we can find other things we can put in here. Stackable, right, and we want to put in this right here. Oh, we're going to do stackable 1x1. Yeah, let's do that. Let's do that. Then we can put that in there. We can, nope, that's not what I do. I want to do that. And now add variants so we can have more in there, and we're going to put that one in. Stackable. So we've got two things in there: the small, the short, and the tall stackable 1x1. That's great. So stackable. Let's have a look at that. In here. So that's the calculations. Right. So at the moment we're just showing a box. We're going to fill it with stuff. We're going to do. Let's do. Fill space. Let's do that. Filling a space with stackable stuff. Filling a space with stackable stuff. Right. So this is going to be take a space and do something with it. Let's show start by showing a frame. We can see what we're dealing with. Okay, and now we're also okay, so we're going to start up here. So, right, we're going to put something in this corner for a minute. And we are also going to be no, place something stackable. Is that what we want? No, we want to choose something stackable. Just to help us, maybe I won't bother with that for the minute. Let's just this. Yeah, we'll start simpler and we'll abstract later. So, resolve variance. We need to find stackable things. We need to choose one. I had one a thing for that. Asset random. That'll do. Choose one at random, and we're going to place it in our frame. As you can imagine, it's going to fill the frame. We don't want that. What we want to do is resize the frame. Obviously, you can only place one of them. We'll do for now. Might be enough. We can dig into this next time. Frame size. Get our asset size. This will be our original asset size. Units. We have a crate. Lovely. We have some storage. It meets the right criteria. Not in the way of the door. It's some storage and it's in a room. Not fabulous, but it's a start. And we may or may not dig deeper. Right, so what I'm going to bring out the seed so that we can vary it a bit more. I'm going to do the other ones. I don't want these, so we can, let's do it like this. I can introduce something called twist. So if we've got a seed here and we pass the same seed into each of these, we're going to get the same object, which makes sense, but we don't really want that because we want to be a bit more varied. So how do we go from a single seed to multiple seeds? Well, there's a couple of ways. One in here where we've done the choice, we get the new seed out. We could pass that in and then chain them together. Maybe we should do that. Do that. It might get more complicated as with lots of iteration involved. So sometimes it's easier to basically, rather than create these dependencies, chains of seeds, is to just branch the seed into different streams. And there's a operator for that, which is called twist. And if we twist once, we'll get a new seed. And then if we twist a variant, we can vary the twist. So you can get basically different seed streams. Now, we haven't actually got 4 different choices because there's only 2 things to choose from. I think that might just be bad luck. If we bring this out to here, we can see where we're going with the right content. I'm just going to feed it off the same seed. Doink. There we go. We now have choice between the 2. 3 of them have been the tall one and 1 is the shorter one. And that will go with the room seed now. We can fiddle with here. Okay, so our content will vary with the room seed. Good. Oh, I think I'm going to stop there. We've set the groundwork. Filling that space, I guess, is the tantalizing bit. I'm going to do that next time because whilst the simple fill of space is like stacker stuff, I don't want to rush that because there's going to be some other funky things we can do. Maybe we could. I just do a grid. Grid, and I could have do a grid, and then I can have different height stacks when depending on the size. Do I want to do that? I'm going to make you wait. Next time, stacks of boxes. Everyone likes crates, but we have some storage. We have storage in every room, but hey, we have storage. Well, let's manage to squeeze them in at the edge. Yep. Let us call it a day. Oh. Not quite the visual impact that I would want for the end of a stream, but should I chat? I should. Do a grid. Right, quick grid. I might have to just zoom through this. Fill space stackable. Yes. Fill space. Do 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 do. Do 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 do. Okay, now where did I do this? Okay, stack is going to start with just a single thing. We're going to pass in the assets to this, so the grid is going to be configurable by a list of assets, so they can all share the same footprint. And time for this, a row. Right, I'm going to use my favourite stacking, all stackability. No surprise that we get the stacker deployed. This is we've used this before, I think. A helper for stacking objects together. This is a row. We have a row of these little stacks, and then a grid of those, a series of rows making a grid. So the rows is going to be an X. Object size we will extract further up. All we need in the two recursive bits. So lower and upper, and it's a stack of stacks. That the assets, that the seed is that, and that's our object. Forwarding on the assets. Need needs to be varied. So row, and our grid is size in X, yeah. And the grid is going to be the same. Stacker, splitter, stacker, merger, frame, select. This is Y this time. Object size. Okay. Control output. So I'm going to recurse as well to the grid. Set of objects, these are going to be the rows. The object is the row. object X we will need to create. I'll call it that. Assets again, propagate, and C. Like so. Here we go. Speed running a grid of stuff for your entertainment. Fill space. No, we're not doing this anymore. We are doing this. Our grid object size. We will use. So we will use first one and get dimensions. This will be our Y size Y. Assets there, seed there, bang. We're not doing anything with it. Right, storage, stackable. We are. Why is that not done anything? Have we broken it? What's going on? Y-axis, merger, object, size, place, choose one at random. What happened? Grid. I wonder if it's not. Oh, I think the. Anyway. Oh, here we go. Ah, the bounds is the second member. Use that here, not that. Ta-da! Wow, look at that. We have storage. Not a stack yet, but the different heights give a bit of impression of that. So there you go. Ah, nice. We stack. Should we stack? Let's stack. So with a stack like this, I might just do a recursion thing. Where's it gone? Stack. Yeah. So we can. How much? Is there enough space left in the height to place another object? Chosen thing is the logic. So if we've got our, this is our space we're filling. We need to see if the Z has got room for another one of these. So let's do if the asset height is less than the space, then we can add another one. And then chop it off and carry on. And what we're going to do is take this and split off vertically the height of the asset, and then recurse on the remainder, which will be smaller because we'll have chopped the bottom off, and then we'll see if anything can go on top. We also probably want to randomize the number of them. We'll do that as a parameter as well. We can bail on count, so we'll add that as well in a minute. So we're going to recurse here on the remainder. Not the same thing. We want the stack. Is this one? Feed that in and do that. Now we've got full stacks. Oh, look at that. This room is getting full and it's stopping at the point where it can't do any more. We'll make the room bigger and we'll get more stuff. Oh. Are we? Okay. All right. Like that. I'm just going to add in a count variant as well, which we can do with great. So if we want a quantity is greater than 0 and there's room, logical and, so if there is a quantity and there's that, we'll continue and subtract. Each time we'll reduce the quantity by 1. Okay. And there's nothing there because the default is 0. So that's row. So for each stack, basically here, we want to choose a quantity. We can do that with random. We can have a value from 0 to 5, say. And that needs a speed. And now we have, sometimes we get 1, sometimes we get 2, sometimes we get 3, and then we don't get any more. There we go. That's wonderful. So next time we can look at other ways of stacking, a bit more ad hoc. The other sizes and stacks of those, they can be, might be able to, not easy to mix them together, but we could have it so that if you've started with a larger footprint stack, you can then go to smaller. So that might be a good way of doing it, making it look nice. Like they're 1.5 Sun ones, aren't they? So you wouldn't get 2 on top. And adding a slight bit of variation to everything. Like, it's not quite so perfect. There we go. We have a room full of stuff. Oh, hang on. My final picture needs to be a nice room with that gone. Diagnostic. We suppress the ceilings. There we go. Oh, look at that. Oh, I like that. That's a nice picture to end on. Oh, I know what I can do. Make it even longer. Can you guess what I'm going for? Yes. There we go. Storage. Ta-da! That's better. I'm happy with ending on that. So let's call it a day. I hope you've enjoyed that. I'm going to get some lunch, go for a walk in the park. So we'll do that. Hope you enjoyed it. This is the I'm done now. So till next time, we'll do some more with the storage, but that gives us a nice screenshot to end on. I'm happy with that. Let's go with that.